Alrighty, year 11, welcome back to methods. This is exercise 5b, relations, domain and range, and in my opinion it's pretty straightforward, so we should whiz through this. It should be a short video and you guys can get stuck into some questions. So what's it saying here? In previous chapters we've looked at how to sketch graphs, just we've done lots of that, and now we're going to also be looking at how to represent relations in a more formal way. Perfect. There are a few things we need to know. You need to know what an ordered pair is. An ordered pair is written as an x and y element, with the first coordinate being the x and the second coordinate being the y. Yep. I think we've seen these before. Yep. If we're talking about a relation is a set of ordered pairs. The following are examples of relations. So here you've got relation S, and you've got some ordered pairs here with both with the x and y elements in them. Yep. And they can, notice they're in the braces as well. Yep, and separated by a comma. Cool. It says every relation determines two sets. The set of the first coordinate of the ordered pair is called the domain. So here with the x values, in each of those it defines the domain, or is a set of all the domain, and the second coordinates, so the y ones, are the pair, are the ones that determine the range. Cool. So it says from the above examples, with S here, the domain is, obviously we've got a 1 here, we've got a 1, we've got a 3, we've got a 5. Now you don't need to write 1, 1, 3, 5, you only need to write the 1 once, obviously there. Yep. The range is the second coordinate, the y value, so 1, 2, the 4 and the 6, as you can see there. I think you guys should be able to do that. It says some relations can be defined by a rule relating the elements in the domain to their corresponding elements in the range. In order to define the relation fully, we need to specify both the rule and the domain. For example, the set, so we've got the elements here, we've got the rule, which is y is equal to x plus 1, and it says do that obviously for each of those elements where x is 1, 2, 3 or 4. So again, remember the x coordinate, or the x coordinate defines a domain, so it's asking us to find the y coordinate, or the range values for each of these 1, 2, 3 and 4. So you notice when you got the relationship here, the first value, which is the domain, is specified here. We've got the 1, we've got the 2, we've got the 3, we've got the 4, and to find out what its corresponding a second value is, or the range value, or the y value, we use this rule here. So it's just saying it's going to be the x value plus 1. So here the x value is 1, adding 1 to that, x plus 1 is 2, so it gives us the y value, and so forth and so forth. Yep. Again, you can write out what the domain is for this, and you can write out what the range is for this. It's obviously these values here, 2, 3, 4 and 5. Perfect. You can represent these relations and graph them. Cool. So again, you can put them on a Cartesian axes. Check. You've got your x values along here, you've got your y values along here. Again, if you were just given the rule, we're looking, you'd have to work out each of those points, yep, using the relationship, yep. So here, plotting these values, 1, 2, go across the 1 up to 2, put it, next one's 2, 3, and so forth and so forth, yep. It says if the domain of the relationship is the set of real numbers R, then there are an infinite many number of points. For example, the graph here, where it's asking us to find the points, y equals x plus 1, where x is all real numbers. You notice we're not putting the single points on there. We're actually defining it as a continuous straight line. Perfect. So that's graphing relationships. I think you guys should be all over that. Oh, the arrow diagrams. Well, these are cool. It says a relation may be represented by an arrow diagram. This diagram represents a relationship. Okay, so again we've got some coordinates, some ordered pairs, sorry, and you can see how it works. So the domain value 3 here goes to the y value, or the range value, which goes to 6. Yep. Also 3 goes to 5, and so forth and so forth. Yep. Likewise here, 5, 4, 5, 4, 4, 3, etc., etc. Yep. It says a relationship may be written as a list of ordered pairs, which is not always convenient or possible, because it could be a lot of ordered pairs, or it might be a rule with a specified or implied domain. Relationship can be represented by a graph or an arrow diagram, which we've just had the chat about. Perfect. All right, turning over the page. Oh, cool. It's doing some sketching. Yep. Sketch the graphs of each of the following and state its domain and range. Alright, so here we've got some coordinates, x and y as ordered pairs, that we can put onto a Cartesian plane. Yep, I reckon you guys could do that. Negative 2, 1, go across to negative 2, go down to negative 1, put the dot, etc., etc. When they're asking, first of all, what the domain is, yep, remember you're looking at the first value of the ordered pairs. Yep, so the x value. So again, you're going to list them. Negative 2, negative 1, negative 1, 0, 1. You don't need to list negative 1 twice, you can just list it once. Yep, so we've listed the domain. Notice it's inside these braces. Range here is the y value of the, or second value of the ordered pair. Negative 1, negative 1. You don't need to write it twice, just write once. 1, 1, negative 1. So it's really just negative 1 and 1. Yep. Cool. Here, oh, this one. It's a circle. Yep, we did that the other day. Yep. If you sketch this, again, working out what the domain is, it's really looking at which values along the x-axis this graph exists between. So on the x-axis, it starts here at negative 1 and goes across to this point here at 1. So the domain is between negative 1 and 1. So x is greater than negative 1 and x is less than 1. So it's existing between those is the way we write that. Likewise, to find the range, it's the y values. Yep. So the graph, or the circle, starts here at negative 1 and exists up to positive 1. Yep. So again, the range, we're looking at how far up this way and this way between on the y-axis, or the values of y for which it exists. Y is going to be greater than or equal to negative 1 here, and it's going to be less than or equal to 1. So it's below here. Check. Oh, cool. This time we're actually given a rule to work this out. And they're saying here, for the domain, they want you to sketch it only for values of x that are greater than or equal to 0. Yep. So it's very tempting to sketch this and just do it, but make sure you're only drawing it for values of x that are greater than or equal to 0. Yep. So again, you'd sketch your graph, which we learnt a long time ago, but here is our domain, which is on our x-axis. Notice we're only sketching it this way. Let me use my fancy pen. I haven't used it today. Yep, so here is 0. We're only sketching it greater than or equal to 0. So it's only being sketched this way. Yep, from x equals 0. You can see obviously that keeps on going down that way as well. Now again, when you have to define the domain and range, again the domain is whereabouts on the x-axis or exist, or the x values exist. Here it's going to exist from 0 onwards until infinity. Yep. So again, whether you wrote it like that, or you say, hey, it's going to exist for all positive real values, and unions and includes 0. Yep, so real positive numbers are 1 onwards. We're also saying, yeah, it's including 0. Notice that it's including 0 because it's got the enclosed circle there. In terms of the, let me delete these here. In terms of the range, remember the range is how far on the y-axis, or the values of y for which this is going to exist. So again, it starts here at negative 2 on the y-axis, and it's only sketched, it goes down this way. Yep, this is going to keep on going down forever this way. So the way you would define it, the range, it goes from down here, which is infinity or negative infinity, goes all the way up to 2. Yep. Notice can never actually get to negative infinity, so it's a round bracket, and it includes 2 because it had the closed circle there. So it's got the square bracket. because it includes it. Yep. Notice again, there's different ways in which you can write these. Yep. Yeah, you could have used this notation to describe the domain, like they're doing with this one here. Just because you haven't written exactly the same notation as the back of the book doesn't mean it's incorrect. Yep, there are different ways you can describe the domain and range, or different notation. Sorry. Alrighty, last one here. We've got what have they got? Oh, we've got a rule. So we can sketch that. They're saying sketch it between -1 and 2. Yep. Oh, sorry. -1 is the -1 and 2 are the x values, so the domain. Yep. So -1 is here. We're sketching it from, and 2 is where we're sketching it from. So we're going to sketch it in between these here. Yep. We're not sketching it that way. We're not sketching it that side. Yep. Now notice here as well, it's got the square brackets, so we're including the endpoints. There's going to be dots at those points. Yep. Once you've sketched the graph and you've actually included these, you will be able to work out what the domain and range is. Excuse me. So again, after you've sketched it, I should have left those lines there. Yep. Oh, they're nice and straight, Nelly. Yeah. Okay, so if we look at for which values in x this graph exists, it goes from -1 across to 2 here. Yep, so you can see the domain listed. In terms of its range, so looking at how far on the y axis up and down it goes, it starts down here at -3 and goes up to +3. Yep. You don't need to draw these lines on there. I'm just illustrating how I got those. So you can see it's on the y-axis. It's in between. It's sketched in between those there. Yep. I've just visually shown you, but you should be able to see without putting lines there. Cool. We spoke about different notation. That's cool. What's this here? In order to determine the range of a relation, it is necessary to consider the graph. The strategy is used in the following examples. Yep. So for each of the following, it says complete the square, sketch the graph, and state the range. Okay. I'm not going to talk about the process of actually how you go about sketching the graphs. You guys should be all over that now. But once you have actually got the graph sketched, then you should be able to see what the range is. Yep. They're already saying the domain is all real values. Yep. Indeed, this graph is all going to keep on going on forever that way, and it keeps on going on forever that way. Imagine these are fancy. It's going to exist for all real values. Yep. But the range, how far it goes for its y values, is not all real values. So by sketching it, you can see here on the y-axis, there's no values that are going to be below this value on the y-axis. Yep. So if we look at the turning point, which was at 2, 1, this point here is at 1 on the y-axis. Yep. Imagine that's a 1. So the range, it goes from 1 here, and it's going to go up, and it's going to keep on going up forever. These lines keep on going up, and so that's going to go to infinity. So the actual range of this graph is from 1, and it's including it, yep, to positive infinity is the range. What am I doing? Let's get rid of this stuff again. Cool. Second one, again, sketching it using a process. You'll have the graph eventually. Here we've got the turning point. It's a negative quadratic. It's upside down. So here we've got the turning points at 2, -1. Okay, so in this particular case, here's the y value. It's at -1. Whoop, imagine that's a negative. Imagine that's a 1. Whoop, a 1. That's obviously can be read from the turning point. This graph is sketched from here all the way down. This keeps on going that way. That keeps going that way. Goes down to negative infinity. Yep. So you would say the range is from negative infinity to -1. Now, generally the convention is the first value is the lower number or the smaller number, and it goes to the larger number. Yep. So we wouldn't write it goes from -1 to negative infinity. Yeah, the convention in maths is to write the smaller number first and then the later number after that. Alright, it says here, sketch the graph of the relationship x squared plus 2, where the domain goes from negative 2 to 1. Okay, so here you're going to go from negative 2 across to 1 is where we're going to sketch it from. And we can sketch that particular graph. It says, note that the range is not determined by considering the endpoints alone. The minimum value is 2, not 3. Yep. Alrighty, so in this particular case, if we want to know what the range is, yep. So the range in this particular case, again, you're looking here, turning point is at 2, and it goes up. It doesn't go up to infinity. There's an endpoint here, the highest value. The endpoint, in terms of its range, is 6. Yep. So the range is from 2 to 6 in this particular case. Alrighty, last thing. Implied or the maximal domain. It says when the rule for the relationship is written and no domain is stipulated, then it's understood that the domain taken is the largest for which the rule has a meaning. This domain is called the maximal or implied domain. So, for example, the implied domain for y equals x squared is all real values. Yep. And the implied domain of x squared plus y squared is equals 1 is between negative 1 and 1. We'll have a chat more in detail about this later on. So it says here, for each of the following relationships, state the implied domain and the range. Cool. We've got a circle here. Obviously, it's been translated to the right by 1, and it has a radius of 3. Perfect. You can sketch that. Yep. And obviously, by sketching it, you can see where these endpoints are from the center out and so forth. Given that we know this information, you can work out what the implied domain is. Yep. So the domain is looking at for which values of x this is going to exist. So it exists between negative 2 and 4. Yep. Likewise, if we're looking at the range, in terms of its y values it exists for, it exists between negative 3 and 3. Yep. So you can write out the range there. Same difference, semicircle, check. It's got the center at negative 1. It's got a radius of 3. It's got an implied domain. Okay, so again, you can see here it goes between negative 3 and 3. And the range in this particular case, semicircle, it's going from here at 1 up to 4. Yep, so you can work that out. Cool, thank you very much for listening. Fun summary section there, which you guys can put into your fun notes. Alright, bye for now.